Syngap Land. My name is Michael Graglia, and today is Monday, October 31st. It's Halloween 2022, and this is episode 80 of Syngap 10. I got a number of news items for you, and then I want to jump into something pretty intense and serious, so buckle up. This might go over 10 minutes. You know, this morning I got a call from Aaron, who I'll be meeting tomorrow down in Southern California to go to Epilepsy Awareness Day and talk to a lot of neurologists about Syngap 1. It's what we do. Thank you, Aaron, for your help on that. And Aaron was sharing with me that his son Jackson, who you've heard me talk about, just had a birthday. And he was saying, man, when these kids turn 16, 17, you start losing access to some of their medical records and they ask you if your kid can sign something. And just brings up that issue of, you know, when your kids turn 18 and getting guardianship, but actually that issue comes up even sooner and with regard to medical records. So thank goodness for the 190 of us who've signed up for Citizen already, that we already have full control of our medical records. It's such a good system. And I encourage everyone to sign up for their medical records. It's good for research. It's good for our community. It's good for our partners. And it's good for you as parents to help you manage your kids' records. So get on that. I want to thank Alok this morning. Alok is the CEO of Vibe Bio. He's shouting out a new organization every day this week, or 12 or something. And he started with Syngap Research Fund. Really appreciate that, Alok. Cannonball finished last week. I spoke a lot about that in episode 79. We got a new article about the Cannonball and CNBC Make It. Thank you, CNBC. That's awesome. Raised over $156,000. And if you missed them, make sure I shared the links in the show notes to the YouTubes of the interviews with Dr. Ben Prosser, who's working on an ASO for Syngap 1, and with Dr. Heller and others, and an interview with Rarebase, who we're funding with this effort, and that was Omid and Ono. So lots of cool stuff on Cannonball. Not going to talk about that more. If you want the full debrief, go listen to episode 79. There's 4 events coming up this year. Please try to make it to some of them. Tomorrow we're in LA for Epilepsy Awareness Day. Atlanta on the 12th is sold out. It's sold out. If you're a Syngap family, call me. We'll try to sneak you in, but it's sold out. It's going to be a great event on the 12th, and then I'm going up to Boston to speak at something after that, but I think we're having a family dinner on the 13th. Pretty early dinner, actually, on Sunday the 13th. So if you're in Boston, call Sandy. And then Nashville is really shaping up to be epic. So on the Thursday the 1st, we're having a science meeting. That night, we're co-hosting a reception with Invite, links in the show notes. On the 2nd, the Friday, we're having a family meeting. And that night, we're having a caregiver dinner on Friday at Deacon's. So it's going to be an amazing day. I can't wait. Other exciting news before I get to the meaty stuff. Maddie Gillentine at Seattle Children's, Dr. Maddie Gillentine, PhD, put out a tweet this week about how she did a large cohort study on neurodevelopmental disorder incidence. And if you're like, what? They basically got data on 50,000 people and said, what is the cause of this disease? And the predicted incidence of Syngap based on that paper is 4 per 100,000. Now, you've heard me before reference the Lopez Riviera 2019 paper in Brain saying the predicted incidence of Syngap is 6 per 100,000, 1 truncating 5 missense, but whatever. So this is a great new paper by Dr. Gillentine, putting our number at 4 per 100,000, which is, you know, still in that neighborhood, and helps us justify the argument that we sincerely believe that there's thousands of Syngapians out there who just haven't been diagnosed yet. And for the 400 in the US and the 1,200 worldwide who have been diagnosed, we all know how hard and painful that was. And it's really not hard to imagine that a lot of people have had trouble completing that process. So let me jump in on the big thing I wanted to get to today. I'm already at 4 minutes, but we're going to go over. It's fine. Antisense oligonucleotides are something I have talked a lot about. If you are not familiar with the concept, please go back and watch Dr. Prosser's webinar. I have a link in the show notes. I think it was at webinar 63. But if you just Google Prosser on our website, you'll find it. And Dr. Prosser talked about the work he's doing on ASOs. And right around minute 12, he talks about and describes what an ASO is. The way I want you to think about an ASO, though, is a very broad description of a type of medicine that interacts with genes. Think of it as a genetic medicine. It goes in and it deals with genes. And the things to know about ASO is, as opposed to other gene therapies like AAV, that once they're in there, they replicate and they spread. So gene therapy, the way I use the term, because there's a lot of different ways people use the term. Gene therapy, it's one and done. You get it once, it spreads in the body, and that's it. You're living with the consequences. because it replicates as, I'm not going to go down that path. And then ASOs are like medicines. The body uses them up as they take effect, and then you need another dose and another dose and another dose. And that's good because you can titrate, which is going to come up in a second. So Dr. Prosser's webinar on ASOs are very, very good. And the reason I'm talking about ASOs today is there was an article in the New York Times that I tweeted out about a little girl with KCNT1 who had an N of 1 ASO made for her. N of 1 means one patient, right? So before I go further, let's talk about KCNT1, right? We all have Syngap 1. That's why you're listening to this podcast. Syngap 1, haploinsufficiency. One good copy, one bad copy. And we're looking for ASOs that go in and make that good copy work harder. So we're trying to, when by we, I mean Praxis, Stoke, Cadia, Prosser, and Ionis, whoever comes next. All these people have strategies that are looking at the good copy and saying, wow, we don't want to fix all these bad copies because all these different patients have different bad copies. But if we could fix this good copy, boom, we can help a lot of patients. So that's what they're doing. They're trying to make a medicine they can put into most of our kids that'll make the good copy work harder and make up for the bad copy being useless, right? And we're assuming that the bad proteins being made by the bad copy of the Syngap gene are being chewed up by the body and spit out. Okay. And I don't need to say this, but I'm going to say it for the sake of comparison. Syngapians do not die from their disease. This is a lifelong condition. And the seizures are hard to see at first. The seizures tend to develop over time, but they're hard to see at first. So that's Syngap. KCNT1, totally different disease. Like any gene, you have two copies, one from mom, one from dad. But when you have a mutation in KCNT1, it's not a protein truncating mutation. It's very often a missense mutation. Missense mutations means misfolded, right? And that missense mutation gets in there and wreaks havoc. And those kids have very severe seizures early on. And unfortunately, those seizures, this disease can be life limiting. Right? These kids can die from this disease. The number that was given to me was about 20%. So there was a family. This is in the New York Times article. I'm not saying anything that's not public. This is in the New York Times article. There's a family in Switzerland whose little girl, Valeria, was diagnosed with KCNT1, and they called Dr. Tim Yu. Dr. Yu is at Boston Children's. He's one of the very best researchers in this space. He's the guy who made the N of 1 medicine for Millicen, the Batten story. If you don't know it, go look it up. But he agreed to make a medicine for Valeria. And again, KCNT1, unlike Syngap, every kid's got there's a few mutations and they're missense, and the missenses are a problem. So Dr. Yu started working on a medicine for Valeria's mutation. And there's two characters in this story. The other one is Lucy. And Lucy's family lives near Boston Children's, and they had the same mutation as Valeria, so they got involved in this too. I'm skipping a lot of steps here, but it doesn't matter. There's Valeria and there's Lucy. And Valeria's family worked with Dr. Yu and funded this work to make a medicine for Valeria. Because again, very serious disease. Could be life-limiting. Nobody wants that for their child. She was dosed about 11 months later. And the way they dosed is they dose over time, right? So the dosing goes up, right? Because it's an ASO. So you give a little bit, it goes away. Okay, that worked. Let's give a little bit more. Let's give a little bit more. This is a feature, not a bug, right? That you can constantly up the dose. Unfortunately, Valeria developed other symptoms and they discontinued treatment and she passed. 6 months after she was dosed, this other little girl, Lucy, started getting dosed. And again, started having other symptoms. A doctor just noticed that these symptoms, ordered an MRI, and the MRI told them she had water on the brain, hydrocephaly. And so they did two things. They stopped the ASOs and they shunted the brain. So they got the water out of the brain. They sort of flush it through another part of the body. And she got better in terms of the hydrocephaly. But she was off the medicine, so the seizures came back. And the second to last paragraph of this very well-written article says the family is considering going back on the medicine because these seizures are horrible. So there's a lot there, right? And the reason I bring it up is a child with a rare neurological disease was given an ASO and died. And yet Mike is on this podcast every other week talking about how excited he is and how we need to be ready for an ASO for our kids. Mike, what's up? Well, here's what's up. They're different, right? ASOs are a broad class of disease. ASOs are a broad class of medicine, a small piece of RNA that goes in and addresses specific genes. And what Dr. Yu did for Mila and what he did for Valeria and what they're going to keep doing for kids with genetic diseases is building ASOs that can go in and help deal with whatever complicated molecular biology is going on. And what we've got is Stoke, Praxis, Acadia, Ben, Ionis, whoever's next, working on not on going in and knocking down emiscence, but on making the wild type allele, the good copy, work harder. And because they're developing these medicines for our entire population, they're taking a lot longer. Like Timmy was able to make this medicine for Valeria pretty quickly. Same thing for Mila. And yet for us, we're like, why isn't Stoke done yet? Well, because the safety and the toxicology and all the things they're doing to make sure that we really understand this before we start dosing in humans is taking time. So a lot of mice are getting treated right now, and then they're going to go to non-human primates, which is dogs and monkeys and whatever. And then eventually when they are sure that they are understand really how this is going to work and what the safety profile is, they'll be able to dose in humans. But we're going to get that call, guys. Like our children have epilepsy, autism, sleep, blah, 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 blah. But all of those diagnoses are because our children have a deficiency in Syngap1. And the current hypothesis, some of the smartest people we know, is that you can address that deficiency in Syngap1 by plopping in an ASO and making the good copy work harder. So, yes, we should remain hopeful and optimistic about an ASO really helping us improve our children's quality of life. And given that an ASO is really just a name for a kind of drug, and there's a lot of different drugs out there, and there's a lot of different ASOs out there, and there's a lot of different genetic diseases out there that are all very different, you're going to hear good stories and bad stories, right? You're going to hear Mila, the Millicent extended her life, and for a little while her symptoms got a little better. She ultimately passed, as children with Batten's disease do. Valeria, I'm not saying she died because of the ASO. I'm not saying she died because of KCNT1. That's way above my pay grade, and it's not in the article. But she took the ASO, and she died a few months later, and probably water on the brain was a contributing factor. And so before we as a community are asked to put an ASO into our children, before I'm given the opportunity to put an ASO into Tony, right, to make this really personal, like we're going to be putting these things into mice and monkeys, and we're going to be really trying to make sure we understand the molecular biology. And based on the learnings now we have from this case, you bet your bottom dollar we'll be doing MRIs frequently and checking for water on the brain. So we're learning a lot. We're at an exciting and terrifying time for these novel medicines that we can inject directly into the cerebrospinal fluid. These shots will go in the back and into the brain. That's actually what we want, because we're sick and tired of seeing these children suffer with the epilepsy, the autism, the anxiety, the GI, the sleep. I could go on and on and on. The seizures. And remember Stoke, whose technology is poison exon or tango. I'm not going to go down that path. They are already doing safety trials with a technology similar to what they will do with Syngap1. I mean, different targets, different gene, but exon skipping, right? Poison exon. They're already doing trials right now where humans are being dosed. Angelman has like 5 different companies working on them, at least. I've lost track. So I wanted to bring this up because I don't want to pretend that this didn't happen. And a few families have asked me about it. And I think it's better, if you haven't heard about it, that you now think about it. Go read that New York Times article. It was excellent. And digest it, and then to go read about KCNT1 and be like, whoa. And understand that the future's coming, and as a population, we are, if God is kind, in a year or so, going to have the chance to dose our children with these through clinical trials, with this kind of medicine. And everybody from Stoke, Praxis, Ben, everyone. Ben, by the way, is working on 2 diseases, Syngap1 and STXBP1. STXBP1 because his daughter has it. And he wants to dose his daughter. Like, everyone, nobody wants to make a medicine that contributes to a child's demise. And so we are all working on this. And what I want people to remember is that there's going to be a lot of news and a lot of noise. And at the end of the day, the parents are going to make the call. And you're the parent listening to this. So start reading, start learning, start understanding, start asking questions. Best place to ask those questions is in person. Back to where I began. Come and join us. Come and see us in LA tomorrow. Come to the Atlanta Sparks for Syngap soiree on November 12th. Come to Nashville. Dinners, drinks, science, family. Nashville's going to be amazing. If there's any way you can come to Nashville, come to Nashville. I have a ton of notes and a ton of links in the show notes, and I look forward to your questions. Thanks for listening.